So we're going to do 7.3 homework for Math 2. Okay. So that was due. So Tuesday, it got assigned, so it's due today. Let's see if we can share our screen. And we want to do iPad via cable. See if that'll work. And how about that? It seems to work. Let's get it to shift over this way. And let's just look at what we got. And you'll see that the homework in these sections has the ready, set, go format. Let's see if we can lock rotation. We can get it here. Okay, let's see if any of these are so let's take a look maybe at number 9. How would you do that? Okay, so remember, you can, if you have to, you can always cross multiply. Okay. But it's nice if you can see a ratio. So what would I multiply this by to get to here? And you think, well, the square root of 12 is the square root of 4 times 3. So it really looks like it might just be a 2, right? It might just be a times 2, which is kind of surprising, right? So you look at it and you think those are both irrational numbers. And so it seems like we just have to do C times 2 because, you know, if you want to use, well, strictly speaking, it's multiply by the square root of 4, but okay, so we can do that. Okay, all right triangles are similar. Okay, so how would you work on that one? And so, you know, for that one, you could you can certainly make an argument that you can try and dilate, and so say that you've got right scalene, but I think it's fairly easy to say, you know, so say that you say, okay, well, this is a 4 and 2, and this is a, I don't know, an 8 and 4. And you say, okay, they're proportional, but then you say, well, what if I just did this, made this an 8 and 5? And similarly, I think a nice argument is that you say, well, I've got a right scalene, a right isosceles. So I've got those two different possibilities. Okay, so then as we so we see that we don't have to worry about something like all right triangles or similar being a hard one to prove. How about all regular polygons are similar to other regular polygons with the same number of sides? Okay, so that seems a little different, right? And so remember, what do you have? You have this idea that for regular polygon, you can divide them into triangles in 180 degrees, right? So if you don't remember that, so let's say I think I've got a regular pentagon here in my clip art, yeah. So I put this regular pentagon in, and you have the same idea, right? Is that with this guy here, make him a little bigger, that you're going to be able to, so you can make 2 diagonals, so you can make 3 triangles, 180, 180, 180. But what you have is that out of these 540 degrees divided by 5, each angle is 108. So you get these angles of the same size. And that's going to be true then if you dilate. And so you kind of imagine, well, what if I have my center of dilation be this corner, and I keep all the same angles, can I dilate it that way? And it seems like, you could make your argument that way. Okay, so we look at 12, and we like that one, right? So we have double, sides doubled, and angles the same. So that looks like that side angle side similarity. In this one, we got angle. And so you say, well, they've both got 38-degree angle. And remember, they both have this corner. And so if two of the three angles are the same, then the third angle has to be the same. And remember, if you have that inverse argument, right? So if corresponding angles are equal, then what happens? Then they must be parallel. Okay, so you have that there. Okay, and so we look at this one, and this looks a little more dubious, right? So 4 to 5, so it's 25% more. Okay, so what's 25% of this one? 99. Well, actually, so these two look like they're in proportion. And then the last one, so 25% of that is 0.625. So you say, yeah, so all three sides are in proportion, so that one works. And then how about this one? So you have 40 degrees, 40 degrees. These angles are what? So remember what you call those. So they're at a vertex there, so they're vertical angles. Okay, so at a vertex, vertical angles. Okay, so what do you have to do with this one? Okay, so you think, well, I'm going to maybe rotate around D, and then I'm going to do maybe a rotation and do a translation, and then do a dilation. Okay, so remember, dilation can sometimes make something smaller. This one looks like a pure 90 degree rotation, and then a reflection, right? So once you get down to here and have them sort of touching each other, then do a reflection. So it's interesting, right? So on say 18, 8 to 4 is like 6 to 3. You can do that. Or you could say, you can equally well say, so that's saying I'm going to compare a side to a side, right? But you could also say, I'm going to compare my middle to my small, and that should equal your middle to your small. You can also flip it over and say my little to my medium. So you can do those sorts of comparisons. Okay, and I think okay, so let's call that our homework session, 7.3 homework.